Hi everyone, in this video we will see how to conduct test of independence on Tier 84 or Tier 84 plus. So test of independence is a chi-square test that determines if two categories, two factors are independent of each other or not. So the first thing you would need to do is enter the data into your calculator. The data for test of independence gets entered into a matrix, which is right up here above x to the -1. So to access a matrix, you would hit second, x to the -1, and these are the names of the matrices, A, B, C, D, and so on. So you could enter data in any of your available matrix. So we'll leave it at highlighted at 1. Scroll to edit because you need to edit the matrix to enter the data. Hit enter. And so the first thing you would do is type in the dimensions of the matrix based on your data given. So we don't have any data yet, so we'll leave it at this for now. And once you're done entering the matrix, you would quit out of here. Second mode to quit. To do the test, next step is you would go to stat, go to tests, and you need to find the chi-square test. So you go down, it's option C. So scroll down to option C. And if you go further down and look at D, that's also chi-square, but that's GOF, goodness of fit. That's not the one you want. You want option C, which is just chi-square test, which is the test of independence. You would hit enter on that, and it's asking you for observed matrix and expected matrix because you would need two sets of data values for it, and you would hit either calculate or you could even draw out the distribution for it. Okay, so let's find a question to follow through on this. So let's go out of this. And we would need to enter data in matrix. So let's access matrix function, second x to the -1, scroll over to edit, hit enter, and let's see, what do we need to put in here? So let's go to a question and this first example. So it states that in a volunteer group, adults 21 and older volunteer from 1 to 9 hours each week to spend time with a disabled senior citizen. The program recruits among community college students, four-year college students, and non-students. In the table is a sample of adult volunteers and the number of hours they volunteered. So this is the actual data as in it was observed. So this is your observed data. And the two categories that you have is the type of volunteer, whether it's community college, four-year, or non-student, and then the hours that they volunteered. Categories being either 1 to 3 hours or 4 to 6 hours or 7 to 9 hours. So this is your data value table, and on the margins are the totals for rows and columns. So we will take our the inside, the 9 data values for 3 rows and then the 3 columns and enter that. So probably make a note of these somewhere: 111, 96, 48, 96, 133, 61, 91, 150, and 53 are our observed values. So let's go back to a calculator. So notice there are, actually, let's go back to question real quick. We need to enter the dimensions of the matrix. So not including the totals. That's not our data values. So the dimensions are 3 rows of 3 types of volunteer and 3 columns for categories of hours. So it's a 3 by 3 matrix. So you would type in 3 and enter on that, and 3 again and enter on that. So see, you get a 3 by 3 matrix with 0 entries, and you would start typing in the values 1 row at a time. So the first entry was 111. Type it in, hit enter. Next entry in that row was 96, and then 48. Once you enter, it will automatically jump down to row 2 column 1, which is indicated by here, row by column. Okay, so let's enter the rest of the data values. 96, 133, 61, and now the last row was 91, 150, and 53. Okay, so our data is in. Let's go back to our question real quick. So is the number of hours volunteered independent of the type of volunteer? So to check that, we do need expected values, as in what is usually expected, and is this different from what's expected. So for that reason, we need to calculate the expected values, which does come with a formula. So you could manually make up a table for each expected value for each cell. It's given by the row total times the column total divided by the grand total here. But we do not need to do that. Our calculator is able to do that for us. All we need to do is populate an empty matrix when we are conducting the test. So make sure that you know where your observed data is. It's in matrix A, right? So let's quit from here. And I do know all the rest of my matrices were empty. So let's go to our test. So stat, tests, option. Let's go from top, bottom up. So you can scroll up and go up to C, which might be just a little bit shorter. So chi-square test is an independence test. Hit on that. Observed is in A, and expected, we could use B. So what the calculator does is it will use that formula and make up the expected matrix for you. Let's say you had a name of a matrix here that was already populated and you didn't want to use that and you wanted to use another matrix that was empty. To do that, you would go to the matrix function again. So second x to the minus 1. And so see, you can tell which matrix is not empty. It will have dimensions next to it. So you will leave it on the names, go down to the name that you want to pick. So let's say C. Let's say my B was not available. So you will highlight number 3 for C. And we only want the name of it. So we'll keep it under the names and hit enter. And it will bring up C for you here. Let's come down to calculate, enter on that. And there's your information that you need to conduct your test. You have the chi-square test statistic 12.99, p-value 0.0113, and degrees of freedom at 4 is given by the number of rows, which was 3 minus 1, times number of columns, which was also 3 minus the 1, so 2 by 2, which is 4. Okay, so, and if you want to take a look at your expected values now, so you could go back to your matrix, second matrix, and see option 3. Let's go to edit and come down to our expected matrix, which is now populated with the expected values. Okay, so this is how you conduct independence test on TI-84 Plus.